Hello dear students, today we will discuss about the remaining past paper questions. You know that we have discussed 15 questions in the previous video. So today in this video we will start from question number 16. Question number 16 is, the diagram shows the dimensions of an elastic cord. It is clearly shown in the figure. Use it to project a stone. The tension in the cord is T. Okay. When the cord is pulled into the shape shown, which force does the elastic cord exert on the stone? It's very easy. Just see here. If you will consider this is a triangle, let us consider this is A, this is B, and this one is C. How to find this side AC? You know that there is a theorem that is hypotenuse square, that is 10 square, is equal to 6 square plus AC square. And what is AC square? AC square is equal to 100 minus 36. That is equal to 64. So what is AC? AC is equal to 8 centimeter. This is 8 centimeter. Now you know all the sides of a triangle. If you want now this angle, how to find this angle? We can easily find it. Let us consider, we will take the trigonometric function, that is sine theta. What is sine theta? You know that sine theta is perpendicular divided by hypotenuse. That is equal to, or you can say perpendicular is actually equal to the opposite side, and hypotenuse, you know that is opposite to that of the 90 degree. So perpendicular is 8 divided by hypotenuse is 10. Okay. Now we will find cos theta. What is cos theta? Cos theta is equal to base divided by hypotenuse. That is adjacent divided by hypotenuse. Base is equal to 6, hypotenuse is equal to 10. Now we are aware about sine theta and cos theta. Is it clear? So now the point is, if you take this T, that is the tension along this cord, we will resolve these two components, this T, into two components, along this component and along this component. What is the first component? Along this horizontal one, horizontal component will be equal to T cos theta, and this T cos theta is equal to T multiplied by, what is cos theta? You know that is 6 divided by 10. That is equal to 60 divided by 10. Clear? Now we will take the vertical component, that is equal to T sin theta. So it is equal to T multiplied by, what is sin theta? Sin theta is 8 divided by 10. I think that is equal to 8T divided by 10. Am I right? Okay. Now these two components we found. These two components. T cos theta and this is T sin theta. Both the components we know now. Now we will find total elastic force does the elastic cord extend on the stone. So you know that there are two tensions. This one tension along this line and this one tension is along this elastic cord. So we will take, that is 2 times of T. That is equal to this component and this component. You know that this component will be neglected by this component. But this T component also shows this, if we will take this line A, B, C, and this is D. This BD, along BD, the tension shows another component along the horizontal direction. So it becomes 2 times of this horizontal component. This is the horizontal one. Clear? What is the horizontal component? Which one is the horizontal component? This is the horizontal component. So we will take 2 times of 60 divided by 10. I think this is 12 divided by 10, and this is T. So this will be equal to 6T divided by 5. This will be the total force along these chords. You understand my point? Which is the correct option? That is this one. Okay. Okay. Now there is another question, that is, a box of weight 40 Newton is pushed with a horizontal force of 20 Newton along level ground for a distance of 2.4 meter. The box is then lifted at a constant velocity through a height of 1.6 meter by a vertical force. What is the total work done? It's very easy. Just see here. You know that there is actually the force given. We can find the work done easily. Work done is equal to force multiplied by displacement. What is force? Force is 20 Newton. And along the ground for a distance of 2.4 meter. So how much is this? It is 48 Newton meter. Okay. Now you know that the box is then lifted at a constant velocity. When there is a constant velocity, what is the acceleration? When there is constant velocity, acceleration is 0. There is no acceleration. So he says that through a height of 1.6 meter by a vertical force. You know that how much is the weight? Weight is equal to 40 Newton. So if you are applied on an object a weight, that is, there is a weight, there's 40 Newton, this is the force. So we can easily say, and how much it is the height to a height of 1.6 meter. Now how much is work done? Work done is simply equal to force, that is weight, multiplied by distance through which it is lifted. How much height? That is 1.6. When we multiply both the numbers, that is equal to 64. That is 64 Newton meter. How much is that total work done? Now we can easily find out the total work done. Total work done. That is equal to 64 plus 48. 12. This is 112 Newton meter. And you will not find any option among these A, B, C and D. So which is the closest one? Closest is 110 Newton meter. So this will be the answer. Okay, you understand it? I hope you understand. Now there is question number 18. Which statement about efficiency is correct? You know that efficiency is always equal to output divided by input. Maybe if there is output power divided by input power. But both are having same output power, input power, same physical quantities. Efficiency does not have unit. Okay. The joule is the unit of efficiency. The meter is the unit of efficiency. The watt is the unit of efficiency. No, these are incorrect. So the correct option is A. That is, efficiency does not have a unit. Why? Because power, if you will measure the power in watts and divided by is also power. So we can say power, watt, power, watt. Watt divided by watt is cancelled. So efficiency is a number. It is a value. It is a value. Okay. You understand it. I hope you understand. Now there is an 19th question. A plane wave of amplitude A is incident on a surface of area S. You know it clearly. There is area, there is amplitude. So that it is perpendicular to the direction of the travel of wave, the energy, and there is an energy concept, per unit time reaches to the surface E. First of all, you must know the relationship between amplitude, area, and energy, or intensity we can say, and surface area. Energy relationship shows that E is equal to intensity multiplied by surface area. Intensity multiplied by surface area. And there is also a relation that is intensity is directly proportional to the amplitude square, that is square of the amplitude. Now we can easily find it. Just see. You know, there is actually, first of all, what is the energy at the first time? He says there is an amplitude A and surface area is S. And after that, energy per unit time reaches the surface is E. In the initial stage, let us take two stages. Initial stage. Initial state energy, let us consider it is represented by E1. It is equal to K, this is a constant. I, what is the I? That is amplitude square multiplied by surface area. Now there is a new state. What is the new state? New state is the amplitude of the wave is increased by 2A and the area is reduced by half. So new state energy is equal to K. What is the area? That will become 2A square multiplied by surface area is half. It is half. That is equal to K. What is this part? This is 4A square multiplied by S divided by 2. So can we represent it? That is E2 equal to, this will become 2K A square dot S. We can easily find it. This one part is the initial state. Is it the initial state? So what can we write? This is 2 and this is initial state, that is E1. That means final stage, much energy per unit time reaches this smaller surface. So final energy is equal, this is the total, becomes equal to 2 times of initial state. So the correct option is B. I hope you understand. Remember these two relations. Relationship shows, this is the energy relationship between intensity, surface area and energy. I hope you understand easily. Let's go towards the next. Next question is, a steel ball is falling at constant speed in oil. You know that the ball is falling inside the oil. This is the oil. Inside this, the ball is falling in the downward direction. Which graph shows the variation with the time of the gravitational potential energy and kinetic energy of ball? You know that kinetic energy is equal to 1 divided by 2 mv square. Mass will not change. You know mass will not change. Mass is constant. Okay, mass is constant. So kinetic energy depends on what? It is directly related with the velocity. And he says in the question, a steel ball is falling at constant speed. That means velocity is constant. This one is constant. If this is constant, can we say kinetic energy is constant? Yes, kinetic energy is constant. Where we are finding the kinetic energy is constant? Is in A, B, C or D? Clearly this is in B. And next point is potential energy. You know that this ball is reached at this place after some time. But initially it is having this height. But after some time, it's having this height. So height is changed. When height is changed, height changes. Potential energy is equal to mgh. Gravity acceleration due to gravity is not changed. mg will not change. Not changed. So what will happen? H is changed. Increased or decreased? H is decreased. So definitely the potential energy is in the downward direction graph and this kinetic energy remains the constant. I hope you understand very well. Now there is next question. When a force of 0.80 Newton is applied to a spring, okay, the length of the spring is 90 millimeter. When a force of 1.30, now he increased the force, is applied to the same spring, its length is 115 millimeter. The spring obeys Hooke's law. Okay, what is the spring constant of the spring? First of all, we will find what is the change of force. How much is change? Next time he applied 1.30 Newton. And in first time he applied 0.80 Newton. So how much is the change? That is 0.5 Newton. Now we will find how much is the change of extension. Extension is denoted by x. So what is the next time extension? That is 115 millimeter, 115 millimeter, minus what is the initial stage at that time extension? 90 millimeter. So how much is this? That is 25 mm. Now we will convert, because you know that this is in Newton and we will convert it in millimeter. This is 25 divided by 1000. It will be converted into the meter. It will become 0.025 meter. Is it clear? Now you know that what is the spring constant? Hooke's law. First of all, you know that Hooke's law is equal to force is equal to kx. Now we write here change of force and change of extension. So k is equal to del f divided by del x. What is force? How much is the change of force? That is 0.5 Newton. Divided by how much is the change of extension? 0.025 meter. Now we calculate this. It will come out 20. But you know that force is having unit Newton and extension is meter. So we will take Newton per meter. This is 20 Newton per meter. So the correct option is D option. Thank you for today. Next.